satellites were orbiting Earth total on October 4th, 1957.
Oh, that's Sputnik, right?
I'm waiting for a number.
I'm going to go with 1.
So that launched literally and figuratively the space race.
Right.
NORAD is tracking this.
As well as Santa?
They do track Santa.
I thought that Santa was their only job.
In addition to protecting the free world, they track Santa.
They track Santa.
Yeah.
Right.
Yeah, they got to make sure nothing knocks him out of the sky.
Well, because, listen, let's be honest. You know, once he starts flying near Russia, it's very possible it could happen.
They get all the presents. Yeah. It rains down the presents. So they're tracking satellite launches and their orbits and this sort of thing. And not until early 70s does NORAD publish the data on these satellites. And that's when Donald Kessler said, you know, if this keeps up and we start loading orbital space with these objects, things could happen here that we know happen in the asteroid belt. He thought to himself, if the same thing happens here, it would probably happen on a shorter timescale because the orbital belt is not as large as the asteroid belt. And so you don't need as many satellites as you have asteroids to repeat the same phenomenon. So he wrote a paper exploring this idea. Satellites are being launched at an exponential rate. Okay? So October 4th, 1957, there was 1 satellite. October 4th, 2024, 7,000 satellites. Not all of them operational. About half are dead.
Well, see, there's the problem. We're leaving our junk in space. Space junk.
That's not the only kind of space junk. Was it 2009? There were 2 satellites that actually hit each other.
Oh.
Yes.
I did not know
that actually happened. Okay? Now, consider, if all satellites are going in the same direction, most are going west to east around the Earth, then they're not really in as much risk of hitting each other because they all have to go about the same speed to maintain that orbit.
I think you just made it a solution.
However, not all satellites are launched at the same latitude. If you're launched at a higher latitude, you still have to orbit the center of the Earth, which means you cut diagonally at some angle across the orbits of other satellites.
Now that makes sense.
And some satellites orbit pole to pole. Those tend to be reconnaissance satellites because you go on the other side, peek what's going on,
and
bring that
come back around.
Come back around and send the data back.
Okay.
Okay? All right. And there's some satellites that orbit counter to the others. So, yes, it is a dangerous racetrack.
So we need basically traffic lights in space.
Yes. Yes. Or some other traffic controlling phenomenon. Right? Now, some satellites that are precious, they have certain extra fuel. If they know they're on a collision course, they can just adjust and get out of harm's way.
Now that can't just be a requirement for all satellites?
It's not quite there yet.
Okay.
All right. So, in the early days, no one was taking it seriously. They knew it was an interesting extrapolation. You don't have to worry about it yet.
Right.
Okay?
No, yeah.
All right. So, guess who was the first one to take out their own satellite? America did it.
Well, we are number 1.
If you can show you can take out your own satellite, that means... That means what?
That means you can take out my satellite.
Exactly.
Right.
NASA, upon learning of this anti-satellite test in 1985, is actively designing the forthcoming space station. And it considered how it might alter that design to make it resistant to debris that it might encounter.
Okay.
And to this day, you can find pockmarks on the outer shell. So that's in the 1980s.
Right.
Before China had anything space-related.
Right.
Okay, so China's not even a player yet.
Wow.
Okay. So then we're okay with that. There it is. All right. The years go by, and we finish out the 80s, then the 90s, then the 2000s, and then lo and behold, China did it. It would have been not so bad, except that their satellite was much higher in orbit, where there's hardly any air molecules to slow down the pieces and have them re-enter.
Right. Well, yeah.
Okay. So the very high up ones in geosynchronous orbit, they're pretty safe.
Yeah, they're cool.
They're cool.
Right.
They're just looking down.
Yeah, and they stay in the same spot with the Earth no matter what.
Exactly.
So they're chilling.
They're cool. Middle Earth orbit, those are the ones, if you destroy them, the particles never leave.
Right.
And low Earth orbit, if you destroy them, they'll fall out eventually, not immediately.
Right.
So maybe we're saved by the fact that
they're
they'll
close
come out a
enough
little
to
faster.
deorbit.
before they put other satellites in harm's way. The smithereens that became of that Chinese satellite, most of them are still in orbit. But, okay, we didn't want to risk harm of this actually colliding to Earth.
But did ours deorbit at the...
Yeah, so ours was a low enough Earth orbit, so probably none of those particles remain in orbit.
USA. That's all.
Okay. So then, Russia did it, and then who's left?
India.
So India does it next.
Oh, man.
They take out one of their own satellites. Now everybody can show that they can kick their ass in the satellite.
So now we have mutual assured destruction of satellites. I guess we can all back off.
So now, but the problem is the debris field is no longer just satellites. It's satellite debris.
Wow.
Okay?
That's
the fragments. All right. So now you have all these particles moving how fast? 18,000 miles an hour.
Right.
If you're hit with anything at 18,000 miles an hour, I'm sorry, that's like way faster than a rifle bullet.
Yeah.
Okay.
No, you're vaporized.
Yeah. Well, not your whole body, but just at the point
whatever
where you're
point.
hit. Yeah. It'll just poof.
Yeah.
All right. You got all these fragments.
Yeah.
Now, here's what's interesting, and here's how you get the Kessler effect, now known as the Kessler Syndrome.
Okay.
So the full-up syndrome is either satellite is intentionally destroyed or two do collide. Now you have more pieces than just the two. One satellite and one satellite, now they collide, now they make 100 pieces.
Right.
They have 100 pieces moving at 18,000 miles an hour, scattering away from that collision point.
Well, they're going to hit something.
They're going to hit something. They hit something. They collide that.
Now you got 100,000.
100, and the number of particles that can do harm grows exponentially.
Right.
And it will take satellites out on the time scale of their orbit. A full orbit, low Earth orbit, is about 90 minutes.
90 minutes.
Okay, so what happens is, if that's the time scale of an orbit, and you start busting stuff up, and it starts taking out other satellites,
oh, man,
this will happen fast.
Yeah.
And you have a total annihilation of 100% of all satellites in orbit, just dropping out like flies. Do you realize how much of our economy flows out of satellite and our defense system? Oh my, all of it.
Oh my
Even
goodness.
withdrawing money from an ATM.
I don't have that problem.
Yo,
It's not something I encounter.
I will try to pay you more, Chuck. Okay. I didn't know it was that bad.
Yeah, when you put the card in, it goes, seriously, bro?
So the Kessler Syndrome could be catastrophic to modern civilization as we have come to know it. Now, there's a movie that explored the consequences of the Kessler Syndrome without even naming it that.
Oh, really?
That was the movie Gravity. In it, they get stranded in space.
Right.
Because somebody, I don't remember who, destroys one of their own satellites.
Right.
Scatters debris.
Yes.
And one by one, the satellites get taken out. So that's the Kessler Syndrome. And who knows?
It's horrifying.
It's horrifying. And we don't know really how close we are. There are many more satellites getting launched every year, especially in the Elon Musk.
So yeah, we just keep throwing them up there, huh?
We keep throwing them up there.
Because that's a good idea.
It's just another thing to worry about before you go to sleep.